Welcome to this talk on gRPC and Python, where we will show you how to build fast, scalable APIs for your services. Let's go over some of the things that we're going to cover in this talk. We're going to talk about the history of APIs. We're going to talk about what gRPC is, why you should use it, and what its benefits are. We're going to talk about some of the disadvantages of gRPC. We're going to have a quick demo where we show you how to build a client and server in Python. We're going to talk about some advanced features like interceptors. And finally, we're going to show you how you can serve front ends using gRPC Web. So let's get started. So what is an API? An API stands for Application Programming Interface, which is a set of definitions and protocols for building and integrating application software. What does that mean? Well, an API is just a way for a program to let other programs communicate with it. So in this example here, we see program A has its API that it exposes to allow anything to communicate with it. And program B, if it wants to communicate with program A, will do so via the exposed API. So here program B invokes the API on program A and asks it to do something, and program A can either respond with an OK or an error. Now, APIs are the foundations of modern computing. Almost any major system you see today has a bunch of different components that talk to each other, and they all do this via APIs. The modern web is hugely based on a set of different disparate services, all talking to each other via APIs. And this is enabled by a variety of technologies. So let's take a look at some of the technologies that are used to build web APIs. Early on, we had this technology called SOAP, or Simple Object Access Protocol. Now, this is from the late 90s and early 2000s. This is a fairly complicated and clunky piece of technology. It used XML as its definition language, and it required the use of these things called WSDLs that needed to be shared across the server and client. It was not great. It was clumsy, error-prone, and as a result of which, in the late 2000s, we had this new technology come up that was called REST, or Representational State Transfer. Now, REST is a way of modeling your API as a bunch of resources and enabling or exposing operations on those resources. If you've ever used an API, chances are it's been a REST API. REST was a huge step up from SOAP. It was simpler, it was easy to use, it was easy to understand. It used JSON as its communication language, which is far easier, far simpler, and far more lightweight than XML. Recently, however, we've had some new technologies come up. GraphQL is an API technology that was invented by Facebook. GraphQL allows you to model your API as a graph that your client can then traverse to ensure that it accesses the data it needs in a single, thus avoiding the multiple round trips necessary with REST and SOAP. You'll find GraphQL used heavily in mobile and in scenarios where network bandwidth is a huge concern. Finally, we have these two technologies here, Apache Thrift and gRPC, which are fairly similar. Thrift was built by Facebook, gRPC by Google, but they were both solving the same problem, which is having an API technology that was designed to be strongly typed and high performance. gRPC seems to have won out in terms of adoption. It is far more widely used than Thrift, and that is why we will be focusing on gRPC for the rest of this talk. So, what is gRPC? Well, gRPC is a cross-platform, open-source, high-performance remote procedure call framework, which is a fancy way of saying gRPC is a way to invoke procedures on other services in a very fast and performant way. It uses a bunch of technologies under the hood in order to ensure that this is possible. And we will look into those later on in this talk. The way gRPC works is very simple and very similar to regular APIs. The client makes a request to the server and the server responds. Now let's take a look at some of the advantages of gRPC. gRPC was built from the ground up to be high performance. It uses HTTP2 natively, which has several advantages over HTTP1. HTTP2 has support for binary framing and compression. This ensures that the messages that are sent over the wire are a lot smaller. HTTP2 also has support for multiple multiplexing of a bunch of calls over a single TCP connection. gRPC also has code generation. gRPC, when you share a protobuf file between a client and a server, the client can use the protobuf to generate a client stub. This means that the client doesn't really need to re-implement the API. It already has the interface defined and available for it, and it can just plug it in and start using the API easily. gRPC is very strongly typed. Protobuf files allow you to specify not just the message, but also the type of the message. This leads to the elimination of a huge class of untyped errors that we've seen in previous API technologies such as REST. gRPC also has native support for streaming. It has unary as well as bidirectional duplex streaming support, which means the client and the server can establish a connection and basically just pass messages back and forth. Finally, gRPC has support for deadline or timeouts, which means the client can let the server know how long the server needs to hold the connection open for before it can close the connection on its own. So let's say, as a client, I specified timeout of 1 second. If the server doesn't respond in a second, the server can close the connection. Now let's take a look at some of the disadvantages of gRPC. Well, gRPC is a newer technology. It still has some bugs, but the gRPC team is really good at patching them really quickly. gRPC doesn't really have native support for browsers. If I build a front-end app, I cannot directly talk to a gRPC API like I can with a REST API. There are some new technologies such as gRPC Web or gRPC Gateway that do make it possible for browsers to talk to gRPC APIs, however. gRPC also requires protofiles to be shared between the client and server, as well as client stubs to be generated ahead of time. Now, this means as a client, I just cannot go about invoking any gRPC API that's available out there. I need to have access to the protofile. I need to generate the client stub, and only then can I invoke that API. gRPC is also a little more complicated than REST. It's not horribly hard to use, but it's definitely not as easy as REST, where I can just fire a client up and call any API that's available to me. Finally, gRPC is not as widely adopted as REST, which means if you build a gRPC API, all of your users might not know how to invoke and call that API. Well, now that we've seen these, what are some of the use cases for gRPC? Well, gRPC is really good for service-to-service communication. It's really good if you have a microservices architecture where you have these bunch of different services that are constantly making calls to each other. gRPC lets you make those calls extremely efficiently, extremely quickly, and because you already are able to share the protobuf files, it makes it very rare that you'll get malformed API requests. gRPC is also very useful for point-to-point real-time communication and high-performance, low-latency applications. Anywhere that you need fast speed, gRPC is usually going to outperform an equivalent REST API. Okay, now that we have all of this information available to us, let's actually take a look at the demo to implement a gRPC server and client. Okay, so welcome to the demo. So on the right, you'll see I have a sample project that I have created for the purposes of this demo. It uses Poetry, but you could use any build tool that you want. There's a few important things to focus on, and I'll walk you through this project. So the first thing to notice is this folder called protos, within which I have defined this file called greeting.proto, which is a protobuf file. And what protobuf is it's basically an interface definition language. And what that means is it allows me to define my API in a language agnostic manner. So here you'll see what I've done is I've defined a service called greeter that exposes a method called greet that takes in a greeting request, which is a string called name, and that returns a greeting response, which is a string called greeting. This is the entirety of the API for my service. I have one gRPC service that exposes one method. And what gRPC is going to do under the hood is it's going to take this protobuf file and it's going to generate code for me in whatever language I choose. And I can plug that code into either my server or my client, and it allows them to not worry too much about the interface of the API because they already have that provided to them. Now, the way that's done is through this tool called Prodoc. Prodoc is a tool that ships with gRPC. You can use it to compile this protobuf file into code for a particular language. And I've done that here. If you look in gRPC types, it's created these three different files for me. I only care about these two. This is the actual definition of the protobuf in Python. We don't really need to care too much about this file because it's not really meant for human consumption. And this is the other one, which is the gRPC file. Again, not really meant for human consumption. These are more sort of like stubs that are meant to be used in the code we actually write. The way you do this is by installing a set of libraries, the first of which is called gRPC IO tools, and the other one is MyPy protobuf. You need to install these two libraries in your project. I'm not going to do that here just because they take a really long time to install, and I already have them installed. Once that's done, you can run this prodoc command here. I'm not going to get into the details of prodoc, but prodoc is basically a way to tell gRPC to take my protobuf file that you see here and generate these files for me. Okay, now that we have our code generated and available for us, we can go ahead and start looking at the implementation of our server. Now, if you noticed in our protobuf file, we had one method called greet. And so any server that we build has to implement this method here. And that's exactly what we're doing. You'll notice I've created this folder called servicers just because I like to create a different file for the implementation of each method, but that is totally up to you. It's just a conversation, a convention that I focus on. But within my servicers folder, I have this file called greeter.py. And what you'll see what I'm doing here is, I'm importing gRPC. But from this actual compiled files that we have here, I am importing the request definition, the response definition, and the servicer definition. And that comes from this file here, as well as this file here. Once we have that, I'm going to actually go ahead and implement that greet method. And you see here, I have the definition for the greet method. It takes in a greeting request and it returns a greeting response. And the actual implementation is fairly simple for this demo. I'm just taking the name of the gRPC request and I'm just like appending it to the string called hello. So whatever I pass in as the name, I'm just going to get a hello name back as a response. And this is basically the implementation of everything that you see here. Now that we have this implemented over here, we kind of need some sort of gRPC server to accept and serve clients. And that is done by this file called server.py, which again, super simple. Import gRPC. There's one important thing to note here. Again, from the compiled code that we have, we need to import this file called add greeter servicer to server. And you'll notice that that comes from here. You notice this add greeter servicer to server. What this method does is it takes that servicer that we've just defined here, and it's going to add it to the gRPC server. And for those of you that come from Django land, this is sort of adding, this is analogous to adding a URL path to your Django server. So now that we have that in, we also need to import the actual implementation of the greeter. And then the server defines a single method called serve. What this does is I'm going to start a gRPC.server in a thread pool. And then I call this method called add greeter servicer to server. And I supply this method called greeter in. And what that's going to do is it's going to take the server that I just created here, and it's going to add this method onto that server. So that that server that I've just created can actually serve clients requesting the greet method. I'm going to specify the port. I'm going to start the server, and it's just going to lock and run. And now, because I use Poetry, I can basically just define a simple script, a simple command to run the server. And I'm actually going to do that right now. I am actually going to run the server. So and as you can see here, I'm sorry, my server is running and it started. Now that we have the server up and running, let's take a look at defining our gRPC client. Again, it's fairly simple. I have this file called client.py. Again, very simple. From the code definition, from the compiled code, I'm going to again import the greeting request from this file and the stub, the greeter stub from this file here. The greeter stub is basically just a way to let the client know what methods it can call. As in you can see, it has this self.greet, which is a unary gRPC call. So this lets the client know that it can call the greet method, which is a unary method. So if I go back into my client.py here, I've imported the greeter stub and the greeting request. And I have a simple run method here, which is like, what is your name? And then what I'm doing here is I'm creating an insecure channel on gRPC on localhost 50051. That's the port on which my server, which you can see here, is running on, port 50051. Once that's done, I am going to create an instance of this greeter stub that I've just imported, pass the channel into that. Once that's done, I'm actually going to create a request that I wish to send over. And my request is basically just an instance of this message that I've created here. It takes one input called name. So I'm going to pass that in, which is like, what is your name? And the response is going to, And then I'm just going to call the greet method on that stub. And I'm just going to print the response on the screen. Very simple. Let's call it and see if it works. So I'm going to go to programming Python gRPC demo. And I'm going to do poetry run, and I think it's called run gRPC client. So let's run this method. Here, what is your name? I'm going to type my name in. Boom. It made the call to the server. I got a response. There we have it, folks. gRPC is running. It's very, very simple. This project is available on GitHub if you'd like to take a further look, how this actually works. But that's it for the demo. Thank you. Okay, so now let's look at some advanced features that gRPC provides. We're going to start by looking at interceptors. So what are interceptors? So interceptors are a gRPC concept that allows apps to interact with incoming or outgoing gRPC calls. You could think of this as middleware, but for gRPC. So just like with middleware, interceptors allow you to intercept the incoming message. They allow you to verify certain aspects or certain metadata on the message. And they allow you to either allow the message through or deny the message. However, unlike middleware, which you'll find on a lot of RESTful services, gRPC interceptors can be on both the client as well as the server. So for example, you could have a client interceptor that adds authorization credentials onto every message. And you could have a server interceptor that checks and validates whether those credentials are okay. Some common use cases for interceptors are for logging, monitoring, authentication, validation, as well as adding tracing to your services. So this is sort of how interceptors fit into the regular request response cycle. The client would make a request, which would then be picked up by the client interceptor, which could potentially add some metadata or modify the request in some way, which then gets sent over the wire to a server interceptor, which again can check and validate certain concepts of the metadata or the message before passing it to the server interceptor. So now let's take a look at some kinds of interceptors that gRPC offers us. And gRPC offers us 4 basic types of interceptor. You first have the client unary interceptor, which is an interceptor that lives on the client that is used when you're making unary calls to the server. So this is where you could add some client-side metadata onto the message. For example, let's say you're making a call from a device, a gRPC call from a device to a server. You could add some metadata, such as the device type, the OS installed on the device, etc., along with the contents of the message, and then send it over the wire. You then have a server unary interceptor, which is an interceptor that lives on the server, and again, that is used for unary messages. An example of this is this could check whether the message has authenticated metadata. So whether the message has some sort of username or password or some sort of token that is valid, the server interceptor can check for the validity of that authentication data that you've provided and decide whether to allow the message to continue or terminate the cycle. Then we have the client stream interceptor, which is the version of the client unary interceptor, but that's used when you have streaming messages between the client and server. So an example of this would be if you, for example, your client is sending packets of video over a client stream, the client interceptor could add the checksum for each packet that's sent over that stream. And then finally, we have the server stream interceptor, which is the version of the server unary interceptor that's used for streaming messages. Again, this lives on the server, And an example of this is this could check the value of the checksum that has been sent by the client and check that against the actual message and see whether it's valid, or if not, it could decide to ask the client to resend that packet of data. All right, that's it for interceptors. Now let's take a look about how we could serve front ends using gRPC. So gRPC was designed to be a machine-to-machine protocol, which means browsers natively do not support gRPC. In order to get over this limitation, something called gRPC Web was developed. Now, gRPC Web allows browser apps to call gRPC services using the gRPC Web client and protobuf. So gRPC Web is similar to normal gRPC, however, it is a slightly different protocol. It supports HTTP 1.1 as well, making it compatible with most modern browsers. Now, the way this works is it requires the browser to generate a gRPC client from a .proto file, similar to what you would do with a regular gRPC client. That client now lives on the web app, and the browser-based web app will make gRPC calls through that client. Once this is done, you need some sort of translation layer and that's present at the server. And this is usually provided by some sort of proxy, such as NY, or there are other things that you could use as well. The advantage of this is it allows browser apps to benefit from the high performance and low network usage of binary messages that gRPC uses. All right, I hope you enjoyed this talk. Thank you.